Okay, this is question 7e. Mary has wait 10 years before starting her monthly contribution. How much will she then have to pay at the end of each month to generate the same pension fund? Okay. Before we get going, we have to start gathering information in from earlier parts of the problem. And what we had from early parts of the problem is we actually, from section A, we had the monthly interest rate problem. So what we're doing now is that is the monthly interest rate from part A. And we're going to need this because this is to do with monthly interest. She wants to have the same pension fund. So in part D, we had the same pension fund. The part D, the pension fund is 155,352. So that came in from part D. So that's basically just gathering some information together. It's a saving scheme. She is a future value problem. She wants to get her money into the future. So therefore she's using the future value formula. We are trying to calculate the monthly payment. The present, at the end of each month, she's going to be paying a certain amount of money. So that's the A. So therefore we can now end up with this formula here. Now, because we know what 1 plus I is, 1 plus I is this. So therefore I'm substituting for 1 plus I in here and raising it to the power of t to match that formula. This is slightly incorrect because t isn't 120. T is running from, well, we'll worry about that in a few minutes. I don't want to second guess. So what I want to do now is just want to pull that out of the way and just get rid of it. And look at some of the notes here, which is quite important. So what we have here is that Mary had originally 20 years to save. She delayed it 10 years. She only has 10 years to raise the funds, which means she is paying at the end of each month for 120 payments. So that value of t is the number of payments, not really the value of t. My bad. Now, she is paying at the end of each month. So she doesn't pay at the beginning of the month into the savings scheme. She pays at the end of the month. End of the month, end of the month. So her last payment is in for how long? Pension in for? Well, it's going to be in for 0. Now, getting back to here. So her last payment is here and she gets the pension here. So how long is that payment in for? Well, that payment is actually in for no time at all. So the first value of t is 0. Now, you've got to remember from the past that there's only 120 payments in total. So what's the highest value of t? Well, it has to be 119. And that, 119 and the 0 gives you 120 payments. So now what we can do is solve the problem. So we have got t isn't 120. T is running from t equals 0, 1, 2, all the way up to 119. That's what t is doing. So therefore, what we have is this formula over here. That's the t to the naught, that's 1, and the final one is going to be 19. And then you're using the formula, which is Sn is equal to a on 1 minus r to the n all over 1 minus r. We know the first payment is equal to a. How do you know the first payment is equal to a? Well, because we're not working from the very, very end. When we're doing the analysis, we work from the very beginning. We work from the very, very end, where t is equal to 0. So when t is equal to 0, when that t is equal to 0, f0 is equal to 12 on the square root of whatever to the power of 0 on a. Anything to the power of 0 is 1. So f0 is equal to a, which is the reason why we've got the a up there. So the first value is a. The multiplying factor is going to be fairly obvious. It's going to be this value here. So that's r, and then you just plug everything in. So you're plugging it into here. When you use the calculator on this, you get that, and then of course you bring that across the other side, divide it into 155,352 to get how much she pays every month in order to achieve her pension level that she wants, and that's the end of the problem. Well, some of you were stuck on 8D, so you obviously want an explanation of why the answer is 20. Well, what's the room temperature? The room temperature, if you go back and read the question, is equal to 20 degrees. That's in the opening part of the question. It's explained there. So when the cup cools down, it's never going to go lower than the surrounding temperature. The surrounding area will keep it at that temperature. So that's the argument there. Some of you are then stuck on 8E. It says use the equation to verify your answer. Right, well, first of all, that equation is given on the very, very front page. Now, this is a negative power. This is a negative power. So how do we convert a negative power? It ends up on the bottom of a fraction. It ends up on the bottom of the fraction. So that's why it goes down to here. And we're looking at time indefinite. When they say time is indefinite, it means time is tending to infinity. And you've got to remember that if time is tending to infinity, then E, which has just got a value of 2.718, can't remember, look at the calculator, 2.7 something or other, and if that's to the power infinity, then this thing here, e to the t, is tending to infinity as well. And certainly e to the kt will tend to infinity, which means this is getting insanely large. So now what you've got is a situation where if you've got a number over something very, 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 very large, then if you're dividing something by something very, 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 very large, it's going to be equal to 0. Hence this thing here. So this whole section is going to disappear and become 0. And if it becomes 0, then the temperature of the object will equal to the temperature of the surrounding room. And the temperature of the surrounding room, which go back and remind you is in the opening section, is equal to 20 degrees. Finish.